Right, so we've got a ball moving on the plane and it's going to collide with the wall. And what we're trying to find is the initial angle, which they've called alpha. We've also been told the coefficient of restitution. Right, now when you approach these problems, you want to introduce as few variables as possible. Now I'm going to have to give some sort of letter to the initial velocity, and then that will allow me now to do my resolving. The problem comes if you introduce too many letters. So say you decide we're going to call that beta and we're going to call that v. Now what's happened now is I've now got alpha, beta, u and v. I've got 4 variables to find, and it's much easier if you don't introduce ones if you don't need it. So I actually don't need that. Okay. We can just work these out. You can call it that if you like, and we're going to replace it in a second. And we'll replace those in just a sec. Well, so let's have a look. What do we know? We want to split our components up. Components of velocity. So going perpendicular to the wall there, you can see that's the opposite side, so that's going to be u sine alpha. And going parallel to the wall, that's going to be u cos alpha. Right, then we can have a look, and if we look at what's happening parallel to the wall, so there is no change in the component of velocity in this direction. So that means that before, the component of velocity is u cos alpha, and that means that's going to be the same as after. So what I can do here is now I know that that is u cos alpha. So I haven't used v and beta at all. The only thing I then need to find is this component here, perpendicular to the wall. So this does mean that rather than using these two, I can just find this, just give this a letter that you like, call that W. Okay, so then we look at perpendicular to the wall. Try to keep my diagrams the same. Okay, so now we're looking perpendicular to the wall, and this is where our coefficient of restitution is going to come in. So we know that E is the speed of separation. Well, the wall doesn't move, so the only thing with speed is B, and I've called that W, and the speed of approach. So that means that I can get that W is 3/4 u sine alpha. And then the best thing to do now is get rid of this W. Okay. And let's instead call that 3/4 u sine alpha. Okay. Right, so that's all we can do with that. What I want to do now is use the information they've been given us. So the kinetic energy after the collision is 60% of the kinetic energy immediately before the collision. Okay, so our now we're going to look at our kinetic energy. Okay, so before, that's going to be a half mu squared. Now you could, if you want, write that as a half m and use the 2 components. So you've got u sine alpha squared plus u cos alpha squared, but remember that sine squared alpha plus cos squared alpha is going to be 1, and that's just going to end up being we're going to end up being the same anyway. Right, after. Okay, so our kinetic energy after now our components. So one of the parallel component stayed the same, but the perpendicular component of velocity has changed. So after, we're going to have a half m, and now I'm going to have u squared cos squared alpha plus 9/16 u squared sine squared alpha, using a half mv squared again. Right, what do we know? So after, so half m, take u squared out, so that's my going after, is 60% of the initial. And what we can see now is quite a few things are going to cancel out here. Okay, so I can get that cos squared alpha plus 9 over 16 sine squared alpha is 0.6 or 3/5. And now it's just a case of solving this trig equation, so it's quite handy to remember that sine squared alpha plus cos squared alpha is 1, which could let me replace the cos squared, or you can replace the sine squared, it doesn't really matter. Okay. And you should then be able to rearrange that and get to this, which you can then solve we can use 3 significant figures because we didn't use gravity's 2 significant figures anywhere, which is the general rule in mechanics. Remember, this is going to be an acute angle if you think about the diagram, so we can take the positive square root when we square root the other side there, and that's absolutely fine. So the key to a lot of these questions is don't introduce extra variables unless you have to, and as soon as you find out what they are, replace them on your diagram, and then you'll be able to solve